For generations, the ultimate prize in cannabis cultivation has been sinsemilla, the pure, unadulterated, seedless flower. To reliably grow it, we need to analyze the plant as a strict economic system governed by a finite, internal energy budget. This animation shows the natural baseline state of the cannabis plant, a diploid. It inherits 2 sets of chromosomes. In this balanced state, the plant operates under a single biological prime directive, reproduction. That reproductive drive creates a vulnerability in the garden. A single rogue male plant releasing pollen into the air can disrupt an entire commercial crop. The moment a female plant catches that pollen, her internal economy instantly shifts. Instead of directing her biological budget into building resinous flowers, she depletes her energy to generate seeds and carry on her lineage. For decades, cultivators have relied on extreme vigilance to weed out male plants and protect their crop's internal energy from accidental pollination, which raises a specific economic question. What happens to a plant's physical potential if you biologically lock it out of the reproductive cycle entirely? The answer lies in a biological workaround known as the triploid plant. This visual equation illustrates how breeders create them. By taking a tetraploid plant, one possessing 4 sets of chromosomes, and crossing it with a standard 2-set diploid, the resulting offspring is a triploid, carrying exactly 3 sets of chromosomes. Despite how it sounds, this involves no foreign DNA splicing or complex gene editing in a laboratory. It is the same agricultural math that farmers have used for generations to cultivate common seedless produce. This identical chromosomal math gave us the seedless watermelon, and it is the exact technique responsible for the seedless bananas hanging in plantations worldwide. Because the triploid inherits 3 sets of chromosomes, it hits a wall during cellular reproduction. You cannot divide 3 evenly by 2. That odd number mathematically locks the plant into a naturally sterile state. This biological dead end is a cultivator's salvation. A triploid plant can be completely enveloped by a cloud of male pollen, and it physically cannot produce a seed, removing the risk of accidental pollination entirely. When seed production stops, the plant is left with a surplus of energy that must be spent elsewhere. We call this the harvest dividend, the biological shift from reproduction to pure physical development. As seen here, the first dividend is yield. Triploids direct resources into biomass, generating buds 30 to 100% larger than diploids. The second dividend is speed. The triploid's efficient internal economy allows it to finish flowering 5 to 10 days earlier. Finally, there is the dividend of potency. The energy surplus allows the plant to increase its production of secondary metabolites. This results in louder aromas, richer flavors from amplified terpenes, and higher concentrations of cannabinoids like THC and CBD. Traditional diploids remain the essential toolkit for breeders who need to preserve lineages and cross new varieties. The triploid is the production-ready result, a flower built specifically for the consumer and the harvest. As cultivation practices evolve, it remains crucial to strictly abide by the laws and edicts of your local jurisdiction regarding home and commercial growing. Because these plants are bred for high potency, you should consult with medical professionals before changing your health routine or starting a new physiological journey. Triploid genetics use basic agricultural math to rebalance a plant's energy budget, ensuring a seedless, high-yielding harvest.
What was I saying? Click. The